Namaste one and all. In this session, let's we understand about precision full wave rectifier. The next experiment title is precision full wave rectifier, design and analysis of precision full wave rectifier, and determine its performance parameters. Okay, that is the next experiment. And then this is the aim, and then operators required, theory concept, and then procedure. Okay, now what do you mean by this precision rectifier? We know the rectification. Okay, we know the basics of rectifiers. Okay, we know the rectifiers. What are the major components we are going to use in the rectifier? Majorly we are go for diode. Okay, diode will going to convert from AC to DC. But what is the purpose of this precision? What is the role of this op-amp? Op-amp will going to give the precise output. Means in the diode there is a threshold voltage. For example, for silicon 0.7, for germanium 0.3. Okay, it is the threshold voltage. Threshold voltage is nothing but minimum voltage to turn on the diode. Okay, but here there is no minimum voltage required to turn on the diode. Here the precision rectifier, the diode will going to act, the op-amp will going to act from the 0.1 from the 0.1 volts only. Okay, that is the main advantage of this precision full wave rectifier or precision half wave rectifier. Okay, that is the main advantage of this precision rectifier. Now, before getting to the actual calculation, let's we understand about this precision half wave rectifier and then precision full wave rectifier. Okay, in the precision full wave half wave rectifier, let's we understand the very basic precision full wave half wave rectifier. Okay, this is the saturating precision half wave rectifier. Okay, and then non-saturating precision half wave rectifier. First, let's discuss about saturating precision half wave rectifier. Okay, you need to observe here. I'm going to give the input signal to the input signal generator supply to the positive terminal. Positive terminal is nothing but a non-inverting terminal. Non-inverting terminal is nothing but a, when we give positive input, it will going to produce positive output only. Okay, that is the beauty of this non-inverting amplifier. Okay, and then inverting terminal I'm going to give to the feedback resistor, feedback path. Okay, input non-inverting terminal to the output terminal, that is nothing but feedback. Okay, you can neglect this diode. First, you can neglect this diode and assume it is a voltage follower. Okay, it is a voltage follower, whatever, without any diode. Now in input korti, it will going to generate the same in the output with diode. With diode, what will going to happen? Let's we understand. This is nothing but a load resistance during positive off cycle. We need to consider both cycle here. One complete cycle only, there is a positive off cycle and a negative off cycle. First, you need to understand positive off cycle. Okay, what will happen when we give positive off cycle, positive supply kottaga? What will going to happen? The op-amp, this op-amp will going to generate positive only. Why? Because it is an inverting amplifier. Sorry, non-inverting amplifier. What is the agenda of non-inverting amplifier? It will going to give when we give positive input, we're going to give positive input output only. Positive output kottaga diode. This diode will going to act as a closed switch. Why? Because anode is connected to output, exactly output positive. Now anode kottaga diode will going to act as a closed switch. Okay, in the positive off cycle, diode will going to act as a closed switch. So that's why I'm going to consider D1 as on. During negative off cycle, assume during during positive off cycle, what will going to happen in the during positive off cycle? D naught is equal to D in. Okay, D naught is equal to D in, because diode will going to on, whatever output will going to, it will going to act as a voltage follower. Okay, and then now let's understand during negative off cycle, whenever we give negative supply to the op amp, it will going to generate negative output only, because it is a non-inverting amplifier. So now negative output generator, the diode will going to act as an open switch. Why? Because now input negative input na anode kottaga, it will going to act as a open switch. Open switch means V0 is equal to 0. So during negative off cycle, D1 is off, V0 is equal to 0. It will going to generate the output in the positive off cycle only. That is a DC output, pulsated DC. Okay, the advantage is precision. It will going to start from 0 only, but in the diode rectification, normal diode rectification, it will going to start from 0.7, because it has normal diode, it has threshold voltage. Okay, now let's understand that is the saturation of your rectifier. Now let's understand non-saturating precision of your rectifier. Or everything is remaining same here, everything is remaining same. If first you neglect these diodes, it is a inverting amplifier. But here I'm going to consider two diodes, first diode 1 and then diode 2. During positive off cycle, what will going to happen? This equation is nothing but inverting amplifier equation, minus RF divided by R1 V in. Okay, we know the inverting amplifier equation. And then during positive off cycle, what will going to happen? During positive off cycle, inverting terminal ge supply kottaga, it will going to generate negative. Okay, negative kottaga, D2 will going to act as a open switch, and then D1 will going to act as a closed switch. The open switch adaga, V0 is equal to 0. V0 is equal to 0. Here observe, V0 is equal to 0 during positive off cycle. Why? Because D2 is off. Whenever we go for negative off cycle, op amp will going to generate positive. D2 will going to on, D1 will going to off. D1 ಯಾಕೆ ಆಫ್ ಆಗಿರುತ್ತೆ? ಇಲ್ಲಿ ನಾವು ನೆಗೆಟಿವ್ ಕೊಟ್ಟಾಗ ಆನೋಡ್ ಗೆ ನೆಗೆಟಿವ್ ಕನೆಕ್ಟ್ ಆದಾಗ D1 will going to off, D2 will going to act as a closed switch. Here in this condition, V0 is equal to V in. How this V0 is equal to V in? Very simple. You need to assume RF divided by R1 is equal to 1. Okay, now it will going to become minus V in the during negative off cycle. Minus V in, you need to consider positive V in. It will going to be in positive off cycle, because whenever we go for negative, now input ಅಲ್ಲಿ negative kottaga, negative supply kottaga, it will going to generate positive, because it is an inverting amplifier. Okay, during positive off cycle, it will going to clip it off. During negative off cycle, it will going to provide positive off cycle. Okay, that is nothing but a non-saturation. Okay, now let's understand about precision full wave rectifier. Okay, precision full wave rectifier. This first rectifier circuit is nothing but a half wave rectifier, precision half wave rectifier, what we see in the last slide. Okay, this circuit is nothing but a summing amplifier, adder. It will going to act as a adder. Okay, this circuit is nothing but a precision half wave rectifier. Now let's understand about full wave rectifier. Okay, what will going to happen? First, let's understand R1, R2. R2 is nothing but a RF. Why I'm going to take a 2R1? Because I need to make this gain is equal to 2. Gain 2 ಮಾಡಬೇಕು ಅಂತ ಹೇಳಿದ್ರೆ we need to consider 2R1. That is nothing but RF 2R1 divided by R1. R1 will going to cancel. A1 is equal to 2. Okay, that is nothing but a gain of this op amp will be 2. Okay, so that's why I'm going to consider RF is equal to 2R1. Okay, first let's understand what will going to happen in the positive off cycle. First, I'm going to give positive supply to the negative terminal, that is nothing but inverting. It will go to generate negative output, because it is an inverting amplifier. Negative kottaga, negative positive supply kottaga, it will go to generate negative. Here D2 will going to act as a closed switch, D1 will going to act as a open switch. Okay, open switch. In that condition, what will be the voltage in the B? What will be the voltage in A? We need to observe. A only output voltage is V in only. V in A is equal to VA is equal to V in only. In VB is equal to minus 2 V in. Minus 2 V in. How we know the gain equation. A is equal to minus RF divided by R1. Is RF is nothing but 2R1. 2R1 divided by R1, that is nothing but a 2. We need to substitute in the V0 is equal to A VI. A is nothing but minus 2 VI. So BL ಏನಿರುತ್ತೆ minus 2 VI. Minus 2 VI. ಇಲ್ಲಿ observe ಮಾಡಿ B in the positive of cycle, that is nothing but a VA is equal to V in only, but in VB that is nothing but 2 minus 2 V in. You can observe here. You can observe here. Yes, ಇಲ್ಲಿ observe ಮಾಡಿ. During positive of cycle, VA is equal to V in, VB is equal to minus 2 V in. How this VB is equal to minus RF divided by R1 V in. RF is nothing but 2 R1 minus R2 R1 divided by R1. R1 will going to get cancelled. Minus 2 V in. VB is nothing but 2 times of input. Okay, for example, I'm going to give 0.5 millivolts input. It will going to generate 1 volts output. Okay, and then VA and VB are 2 inputs of summing amplifier. Summing is nothing but addition. We need to add VA plus VB. What do you mean by VA? V in. VB is nothing but 2 V in. Okay, V in and 2 V in. You need to add. The final equation is R6 divided by RF V in. Okay, you can add here minus V0 is nothing but VA plus V in. Okay, V in is nothing but a R6 divided by R4, that is nothing but a gain VA plus R6 divided by R5 VB. R5 is nothing but R4. Okay, you need to consider here R4 only, and then R6 R4 you are going to get outside, and then VA plus VB minus R6 divided by R4, and then VA is nothing but V in. VB is nothing but 2 minus V in. V in it will going to get cancelled, and then minus will going to get cancelled, and then the output equation is R6 divided by R4 is into V in. During negative off cycle, what will going to happen during negative off cycle? During negative off cycle, I'm going to give negative supply to the op amp. It will going to generate positive. In that time, this diode will going to act as a open switch. That time VB is equal to 0. VB is equal to 0. In that time, you need to add here VA plus VB. VB is equal to 0. Same, whatever condition, everything is same, but VB is equal to 0. Now the equation will become same. V0 is equal to R6 divided by R4 V in. Why? We need this output, so that's why it will going to become positive only. Positive. That is nothing but V0 is equal to R6 divided by R4 into V in. Okay, very simple. And then let's understand the design part now. Okay, now design the precision full wave rectifier circuit to produce. It should produce 2 volts peak output from sine wave input with 0.5 peak value and 1 kilohertz. We need to give 0.5 peak only, not peak to peak. We should give 0.5 peak and then 1 kilohertz frequency. A bipolar op amp with supply voltage VCC 15, VE 15. Choose diode current 500 microampere. Here I is not 50 nanoampere. I should take 500 microampere directly, not IB 100 times of IB max. You should take IB is equal to 500 microampere directly. Okay, now what is the formula for R1? How can I find R1? This R1 directly V by R formula, V by I formula. V is nothing but 0.5, IB is nothing but 500 microampere, 1 kilo ohm will going to come. RF is, we know the RF R2 is nothing but 2 R1. 2 into R1 value 1 is equal to 2 kilo. R3 is nothing but R1 parallel R2, that is nothing but 666. You can take 680 ohm. R4, R5, R1 is equal to 1 kilo ohm. And then you need to find out gain. We know output divided by input. Output namge gottide 2 volts, input 0.5, 4 will going to come. And then A2 op amp yavadu idu. Okay, this enidu gain equation R6 divided by R5. R6 divided by R5. We know the gain 4. We need to find, we know R5 1. Okay, and we need to find R6. R6 is equal to 4 into R5 is equal to 4 kilo ohm. And then R7 is nothing but parallel R4, parallel R5, parallel R6. You are going to get 470 ohms. Okay, this is how you need to design the circuit. Okay, it will ಇದರಲ್ಲಿ ಏನು ಎಕ್ಸ್ಪೆಕ್ಟ್ ಮಾಡ್ತಾ ಇದೀವಿ ಅಂದ್ರೆ 0.5 ಇನ್ಪುಟ್ ಕೊಟ್ರೆ ವಿ ಎ ಇಲ್ಲಿ ವಿ ಎ ಈ ಕಂಡೀಷನ್ ಅಲ್ಲಿ ಎಲ್ಲಿರುತ್ತೆ ವಿ ಎ ಅಬ್ಸರ್ವ್ ಹಿಯರ್ ಇಲ್ಲಿ ಈ ವಿ ಎ ಇನ್ಪುಟ್ ನಾನು 0.5 ಕೊಟ್ರೆ ಇನ್ಪುಟ್ 0.5 ಕೊಟ್ರೆ ಈ ವಿ ಬಿ ಯಲ್ಲಿ 1 ವೋಲ್ಟ್ಸ್ ಇರಬೇಕು ಅಂದ್ರೆ 0.5 into 2 because VB is equal to minus 2 into V in but total output ಅಲ್ಲಿ VA plus VB ಇರಬೇಕು VA plus VB is nothing but total 2 volts ಇರಬೇಕು according to our question. Okay, now I'm going to run. Okay, please simulate as per the circuit diagram. You are going to get easily and then substitute the values R1, R2, R3, R4, R5, R6 according to the circuit diagram. You need to simulate and then here extra part is I'm going to set input 1 kilohertz as per the question. VP is equal to 0.5, not 0.25. You need to put directly the value 0.5 because as per the question, if it is one peak to peak, then you are going to divide it by 2. But here you need to take directly 0.5 and then run Okay, I'm going to get the output. But how to connect this four output oscilloscope? You need to select here. And then one A channel you connected to this side A, and then B you connected to nearer to R5 as per the circuit diagram like this. A, B, we only need 3 channels. Don't neglect that D. Okay, and then output this oscilloscope, this op amp. Okay, I'm going to delete. Already connected, you can check. Okay, yes. Okay, first I'm going to consider here. I'm going to consider A. Please rotate this one A. Okay, A is nothing but red waveform because it is connected to VA. VA is nothing but you need to consider only P, means 500 millivolts. That is nothing but 0.5 volts. Okay, and then what is the B? VB you need to consider this waveform like this. Okay, like this. This is nothing but a 0.5 input. This is nothing but a VB blue color VB 1 box 2 box into, you just rotate here B 1 box 2 box 2 into 500, that is nothing but a 1 volts. That is nothing but a 2 multiplied by input 2 into V in is to 0.5 into 2, that is nothing but a 1 as per the design. And then C should be 2. How to measure this one pink color? C is connected to directly output. Observe here, directly output this waveform ಇಲ್ಲಿ ಕನೆಕ್ಟ್ ಮಾಡಬೇಕು directly output ಗೆ. ಎಷ್ಟು ಬರ್ತಾ ಇದೆ ನೋಡಿ, 2 ಬರಬೇಕು. 1 ಬಾಕ್ಸ್ 2 ಬಾಕ್ಸ್ ನೋಡಿ, ಎರಡೇ ಬಾಕ್ಸ್ ಕವರ್ ಆಗ್ತಾ ಇದೆ. ಜಸ್ಟ್ ಟೇಕ್ ಡೌನ್ ದ ಪೀಕ್ ವ್ಯಾಲ್ಯೂಸ್ ಓನ್ಲಿ. ಪೀಕ್ ವ್ಯಾಲ್ಯೂಸ್ ಇಂಟು ನೋಡಿ 2 into 1, that is nothing but 2 volts. 0.5 ಇನ್ಪುಟ್ ಕೊಟ್ಟಿದ್ದೀವಿ, ರೆಡ್ ನೋಡಿ, ಓನ್ಲಿ ಪೀಕ್ 0.5 ಇನ್ಪುಟ್ ಕೊಟ್ಟಿದ್ದೀವಿ. 0.5 ಯಾವ ತರ ನೋಡೋದು, ಎ ಚಾನಲ್ ಇಟ್ಕೊಂಡು ಇಲ್ಲಿಂದ ಇಲ್ಲಿಗೆ 0.5, that is nothing but 500 millivolts ಅಂದ್ರೆ 0.5 volts ಅಂತ 0.5 ಕೊಟ್ಟಿದ್ದೀವಿ. VB ಎಷ್ಟು ಬರ್ತಾ ಇದೆ, 2 ಬಾಕ್ಸ್ ಕವರ್ ಆಗ್ತಾ ಇದೆ 500. ಇದನ್ನ ಇಲ್ಲಿ ಬಿಡಿ, ಬಿ ಗಿಡಿ 500, that is nothing but 1 volts ಕರೆಕ್ಟ್ ಬರ್ತಾ ಇದೆ. 0.5 1 volts, ಟೋಟಲ್ ಔಟ್ಪುಟ್ 2 volts. ಎಕ್ಸಾಕ್ಟ್ಲಿ 2 ಬಾಕ್ಸ್ ಕವರ್ ಆಗ್ತಾ ಇದೆ. 1 volts per division ಅಂತ ಹೇಳಿದ್ರೆ 2 into 1, that is nothing but 2 volts per division, that is nothing but 2 volts. 1 volts per division into 2, that is nothing but 2 volts. Okay, input 2 ಕೊಟ್ಟಿದ್ದೀವಿ, input 0.5 ಕೊಟ್ಟಿದ್ದೀವಿ. VB ಎಷ್ಟು ಬರ್ತಾ ಇದೆ, 1 volts ಬರ್ತಾ ಇದೆ as per the design, as per the theory concept also. And then output it should be equal to 2.5 1 2 as per the question. Question, observe here, 0.5 output 2. In between VB I'm going to get 1 here, 1 volts. Okay, thank you so much. This is how we need to simulate the precision full wave rectifier and check the output. Thank you so much. You can simulate one simple precision half wave rectifier. You can observe here half wave rectifier. You can observe here. I'm going to get here. I'm going to get pulsated DC. Pulsated DC. Pulsated DC. Pulsated DC. For AC input, I'm going to get pulsated DC. Okay. This is nothing but a half wave rectifier, but in the full wave rectifier, I'm going to get here everything. Positive cycle also, negative cycle. Positive cycle, negative cycle. Every where I'm going to get output. Okay. Thank you. Thank you so much.